Okay, folks, this is chapter 3-2. This is recording number 2. All right, so when you're dealing with a distribution, remember, this is a frequency distribution. This is you know, something that's already happened, it's already been measured. It's not a probability distribution. Probability distribution is something that is going to happen, okay? All right, so there's two things that you typically are looking for is, what's the average value of all of these data points? That's the measure of central tendency. And the other thing you're oftentimes concerned about is how spread out is it? You don't care about the individual data points as much as you care about, in general, how spread out is everything. That would be the measures of dispersion. And that's going to be typically the the variance and the standard deviation. All right, so we just talked about the population standard deviation, and we got this nice succinct formula here. And the blue table is always a procedure table. It's an algorithm. It's a step-by-step process for how to do it, okay? So I'm sure you can read this for yourself on your own, okay? You crank it out. We'll do an example here in just a second. As always, we always have a rounding rule, okay? So the rounding rule is going to be, you're going to round it to one more decimal place than that of the original data. The reason this is important is because, when you start doing these calculations with calculators, you go out however many digits, 10, 15 digits. It's just craziness. You got to round it off to something. And here's the rule. This is how we round it off. Okay, so we're going to look at the comparison of the outdoor paint again. Okay, so I can't do it very readily here on the screen, but you can do it with your book very easily. You bounce back and forth. When you read this algorithm here, it seems almost impossible. You think, oh my gosh, I just don't get it. But as you do the example, if you just go back and forth between the example and the algorithm, you'll see it is not as hard as it looks, okay? So we've got the data for brand A. We're going to find the mu. That's the population mean. What do? We add these guys up on top. Boom, there it is. Divide by the number of data points. Boom, there it is. So that's 35. That's my mu. Now we want to get the x subtract mu. We want to get x subtract mu for each one of these. Okay, so x, again, those are the individual data points. So here's x sub 1 is 10. There it is. X sub 2 is 60. There it is. X sub 3 is 50. There it is. X sub 4 is 40. There it is. 1, 2, 3, 4, 5, 6. Did I miss one? I guess I skipped one or something. So here's x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, x sub 6. So as I've said before, the little subscripts don't mean anything. They're just a way of identifying which data point you're looking at, okay? Okay, so now you've got these deviations, is what he's calling them. A lot of authors would call those the deltas. A delta is just a standard word for differences. So you've got these deviations here, okay? So now, as we've mentioned before, if you add these up, you're going to get 0, right? Minus 25 plus 25, 15 plus 15 plus a negative 15, 5 and negative 5. You add them up, you're going to get 0. So that doesn't help us. So what we want to do is we square each of those. We square them, and that's what we get. Now you find the sum of those squares. Now, why do you find the sum of the squares? Because ultimately what we want is this right here. That's the average, that's the mean of the square of these deviations, right? Because when you add these squares up, add these guys up, divide by the number of data points, what is that? That's just the mean. That's the mean of the squares of the deviations. It's hard to say, but it really is not a difficult concept if you just look at it one step at a time. Okay, and then this is the variance. You take the square root of that in order to get the standard deviation. Now that just comes from right here. That's just the definition. That's what we mean by population variance, and that's what we mean by the population standard deviation. Okay, so what the author is suggesting here is, you know what, this is kind of complicated. Why don't we make a table? And I agree with that. Remember, as before, the A, B, and C, that's just left over from the Excel spreadsheet. That doesn't mean anything. It's, I wish I wish you didn't have it in there, okay? So we've got the values, we have the x minus mu, we've got the x minus mu squared. It kind of helps you keep yourself organized, okay? Give me 1 second. Okay, so now this is very awkward to try to explain this. The ebook here, this book that I'm showing you right now, this is off of the this is the ebook from the publisher's online homework system. This is all correct. Everything is correct here. The printed version of the book, the physical book itself, the 10th edition, at least the one that I have, there's some typos in here. That's for the 10th edition for the instructor's version. I don't know if the same errors are in the 9th edition or even if this example is in the 9th edition. So let me show you what they are just in case you have the same thing in your book. So give me 1 second. Okay, in my edition, I just photocopied the page. There's an error here, it's a typographical error. He has here square each results. He has x bar take away mu quantity squared. And down here he has x bar. Down here he has x bar. That's not correct. It should be just x. It's the summation of the x sub i's. The x sub, you add x. Well, I've already explained all that. Okay, so it's the sum of these squares. All right. It shouldn't be x bar. X bar is just a number. It's just a single number that you calculated. Well, actually, you don't even calculate the x bar in this one. Gosh, I'm getting this all screwed up. You don't even need the x bar here because we're dealing with mu. So it's just a total typographical error, okay? And I just don't know whether it's in your printed edition or not. It's in the instructor's printed edition, but I don't know if it's in your printed edition or not. But what I would point out is that what I just showed you in the electronic version, everything is correct. So look in your book if you have a printed copy and see if it has these mistakes. If it has a mistake, just keep it in mind that that's a mistake. Okay. All right. So now let's get back to the dull stuff here. Okay. So we've got this example here. What does this tell us? It reveals a few things. The square root of the variance gives us a standard deviation. That's pretty much the definition. And then going in the other direction, if you have the standard deviation and you square it, that gives you the variance. Okay, so cool. That's all right. The variance is the average of the square of the distance that each value is from the mean. So read that over a couple times to make sure you understand it. These deltas, these differences, these distances from the mean that each of these data points has, we find the average of the square of those things, okay? And the only reason we do the square is because we don't want to end up with 0. Let's see here. All right, so what is he saying? If the values are near the mean, the variance will be small. If the values are far from the mean, the variance will be large. So that's why we say that the variance and the standard deviation, they give you an idea of what the shape of the data is, or what the distribution is. And then this is what he's saying here is, hey, listen, why are we using squared? It's because we got to get rid of these. We don't want to have any negative values because then we end up with 0, okay? All right. And then why do we take the square root? It's a little bit beyond the scope of this class, but we do that because we squared the distances, so the units are squares. So finding the square unit puts the standard deviation back in the same unit as the raw data. Okay. For our purposes, we just kind of have to do take a little bit of this on faith. Okay. By the way, here's a good point here. When you're finding the square root, I hope you remember from a previous class perhaps, when you take the square root, you actually get 2 values, right? If I take the square root of 9, it's positive 3 and it's negative 3. Well, we don't want the negative value. We only want the positive value. So when we're finding the square root, we always use the positive value. We ignore or we throw out the negative value. Okay, so now we're gonna take a look at this. This is example 315. we're going to find the variance and standard deviation for brand B. So we do the same exact thing. So as before, we crank this out and we come up with an answer, and boom, here we are. We come up with the answer. Now the standard deviation for this one, or the variance, is 41.7. Standard deviation is the square root of that. That's 6.5. So that's 6.5 for that one. And then for this one, it was 17.1. So 6 compared to 17, obviously brand A is spread out a lot more than brand B is. And you can see that just from the cartoon that we had originally. Get back up there to that. As you can see, brand A is all spread out, whereas brand B is, relatively speaking, is kind of centered around the average. Okay, so again, as far as typos are concerned, the electronic version has it correct. In my book, right here, instead of having sigma, they have sigma squared. So that's a typo, all right? Okay, so it's how much variation is there? How variable is it? Okay, when here's a keep this in the back of your mind. Always remember this, kind of how to put all this stuff together here. In summary, if the means are equal, the larger the variance or the standard deviation is, the more variable the data is going to be. How spread out is it? So that's the basic idea behind variance and standard deviation. Okay, so what we just did was the population variance and standard deviation. Sometimes what we want is this sample variance and standard deviation. As an example of why do we want the sample variance and standard deviation? Well, maybe we can't come up with a population variance. Maybe the population is so large that we just can't come up with the numbers. Just the example of the Riverside Community College District, tens of thousands of students, it'd be impossible to get the information from all of those kids, right? So we would use a sample variance and a sample deviation, standard deviation, to draw inferences, and we'll see how we do that later on. In any event, here's how we do the sample variance and standard deviation. It's the same basic concept. What you would think is, well, you just do the same thing, right? Just, do exactly the same thing, divide by n, but unfortunately that doesn't quite work. What we have to do is we divide by, not by n, we divide by n subtract 1. So on the top here, it's going to be the same thing. It's going to be the data points subtract the mean, which in this case is x bar, quantity squared, you add them up, and then you divide by n minus 1, not by n. So that's a very common mistake. So make sure you pay attention to this, okay? All right, so then you do the same thing, you take the standard deviation. So all of these procedures are exactly the same. I'm going to let you walk your way through these examples, but everything is exactly the same. Do the tables, crank it out, okay? All right, so now, these examples, the formula we've used have been the exact formulas that is the definition. However, there are shortcut formulas, okay? And from now on, that's what the author is going to use. And it's just playing around with the algebra, you come up with a different formula, and it's just a lot easier, okay? So here's the formulas. They look intimidating, but I swear they're not. They're not that bad, okay? A source of common errors is people think that this is the same as this, and it's not. You got to look at it very, very carefully. Summation of x squared, that's this guy. Summation of x squared is you take each of the data points and you square it, and then you add it up. Whereas this one here, what inside the parentheses, you add up all of the data points, add them all up, they're inside the parentheses, and then you square what you just added up, okay? So that's what he says here. The summation x squared means you square the values first, square them up, and then you sum them, you add them. This one means you sum the values first, and then you square the sum, okay? So you'll see an example here coming up on this next one. I'm going to have to end this video, though. We'll do the example on the next video.